Now, example 11, right, is a good example to illustrate the rules and properties that you saw in the earlier table. And then what we have in the example 11 is two normally distributed independent variables, and you know everything about them. Okay? And then you want to find the distributions for the linear combinations that you see in part 1, part 2, part 3, and part 4. Now, as long as they are normally distributed and they are independent, then the distributions, any linear distributions of x and y, will always be normal. Which means x plus y, straight away I can write this down as a normal distribution. Okay? Then what do I put in the brackets? Remember this rule? When you have x plus y, this will follow a normal distribution with the two means add together and the two variances you also add together. So that means for our x plus y here, I will have minus 1 plus 10 and then 4 plus 5. Now what you shouldn't do is to say that this is equals to n 9, 9. Now this is because we never equate distributions. Okay, we never equate distributions. So if I want, I can write down one more line to write down the answer. Okay? Now you can try the same for part 3. This is the answer for part 3. Then maybe I can show you part 4. Now part 4, it looks like we have ax minus by. And from our table, we can say that this is the same as a mu 1 plus b mu 2. Then you have a squared sigma 1 square plus b square sigma 2 square. So all you need to do now is to fill in what you see for a, mu 1, and so on. So that's why you have this thing here. Okay? And then all you need to do is to press this on your GC or your calculator. You have this as your answer. Done. Now it's important to make a distinction between 2x and x1 plus x2. Now x1 plus x2 is two different x values considered together. 2x is the same x value considered twice. So they are actually not the same. Okay, and if you work out their distribution using the rules that you see in the table above, you can see that x1 plus x2 is actually normally distributed with mean 2 mu, but variance 2 sigma square, while your 2x is normally distributed with mean 2 mu, but with variance 4 sigma square. So they are not the same. Okay, they have different variances.